All right, so what we're going to try to do is we're going to use the Pythagorean theorem, and we're going to try to find the sides of a right triangle. So since we know it's a right triangle, let's draw it. Sorry for my Bobo pen. It doesn't make straight lines. Okay, so let's read. The length of the longer leg if the right triangle is 22 meters more than 6 times the length of the shorter leg. The length of the hypotenuse is 23 more than 6 times the length of the shorter leg. Okay, so the length of the longer leg of the triangle is 22 meters more than 6 times the length of the shorter triangle. So let's make the shorter side x. So then the other side, the other leg, remember legs are the sides of the right angle, so that has to be 22 meters longer than 6 times the short leg. So that's going to be 6 times the short leg, so 6x plus 22. So then what's the next sentence say? So the next sentence says the length of the hypotenuse, so that's this guy, boop, is 23 more than 6 times the length of the shorter leg. Okay, so over here we have 6 times the length of the shorter leg plus 23. And now we have to find the lengths of the triangle. So in order to do that, we need to find x, and once we find x, then we can plug x back in. So what we know, so what we know is that since this is a right triangle, right, because it has to say right triangle. So it's a right triangle, so we know a squared plus b squared equals c squared. Now a and b have to be the legs. It doesn't matter which leg, but one leg and the other leg. C is definitely the hypotenuse. So the hypotenuse I highlighted in blue, this is definitely the hypotenuse. So let's put those all together. I've got, we'll call this A, we'll call this B, and then this guy has to be C. So we get 6x plus 22 squared plus x squared equals 6x plus 23 squared. And I think I kind of jumped the gun and I labeled them wrong. It doesn't actually matter, but for copying purposes, it does. All right, so now we have just one single equation and the only variable is x. So we're going to have to solve for x, but the problem is there's lots of squareds and those are not our friends. So what we need to do, I'm going to do it off to the side, is we need to FOIL this guy out. Like, what does squared mean? It means times itself. So let's do 6x plus 22 times 6x plus 22. Now there's a lot of ways to FOIL. You do first times first. So 6x times 6x is 36x squared. And then O is for outer. So 6x times 22. That makes positive, let's see, 132x. And then inners, 22 times 6x should also be another 132x. And then 22 times 22, I think that's 484 plus 484. I'm actually going to use it. These are big numbers. Let me just double check. So 6 times 22 is 132. Booyah. And 22 times 22 is 484. Oh my gosh. Okay, so we can put these two together. So this guy became 36x squared plus 264x plus 484. So that was just this guy here let's do more. Let's do this guy. Oh, well, there's nothing to really do. That guy just gets plus x squared. My niece is helping me over here.
Yay!
So now this guy, two things in parentheses, we're going to have to FOIL it out. So again, I'll just write it over here, 6x plus 23 times 6x plus 23. So first, 6 times 6 is 36, x squared. Then outside, 6x times 23 is 138x. And then middles, so another 138x. And then lasts, which is 2. Well, I can't do that one in my head. I'm too tired. 23 times 23. 529. I knew that somewhere. 529. So if I put this together, remember this is on the other side of the equals, I get 36x squared. And then these guys go together, so that makes 276 plus 276x plus 529. And I know you're thinking, sheesh, these are very large numbers. It's actually going to work out pretty amazing in just 1 second. So this is a quadratic equation. In quadratic equation, you need everything on one side and 0 on the other. So let's subtract 36x squared. Let's subtract 276x. And let's subtract 529. Because it's a Bobo pen. Over here, these all cancel, right? So we just have equals 0. But on this side, I got to do a little bit of work. But some really great things are going to happen. So let me get a different color. So if I have 36x squared and I subtract 36x squared, well, that guy's gone. So I only have one single x squared. And now I need to do 264x minus 276x. So one trick for subtraction is always do big minus little and then take the sign of the bigger number. So to get from 64 to 76, we need 12. But since the 276 was bigger, it'll be negative 12x. And then same thing, we need to do positive 484, subtract 529. So 6 would bring us to 490. 10 more would bring us to 500. So that's 16. And then 29 more, 16. 45, negative 45. I think so. So now I've got like this little tiny baby quadratic equation. So can I factor it? I don't know. Let's see. What times is to 45? 1 and 45. But that doesn't add up to 12. 2 does not go in. 3 and 15. Ooh, I like this one. Right? Because we want to make two numbers that times to negative 45, so plus minus. And then add up to negative 12. So since we want it to add up to negative, the bigger number has the minus, and the smaller number has the plus. So this guy double bubbles into x plus 3, x minus 15, and that equals 0. And it turns out if two things are times together and they equal 0, one of them had to be 0. So either x plus 3 was 0, or x minus 15 equals 0. And those are again, little baby equations. This one gives me x equals -3, and this one gives me x equals 15. And you're probably thinking, well, there's two values of x. What do we do? Well, let's look at our picture. Our picture is a real live triangle. Excuse me. So its sides have to be positive. It's not about what the value of x is. It's about what happens when you plug x back into the A side, the B side, and the C side. I think you can tell right here that since this one side, I don't want to use that color. Since this one side is just x, I can't replace it with x equals -3. Like the other ones I could, I'd get positive values. But you can't have a negative size. So I'm not going to use this one. Let's try 15. So my orange side, let me get my orange pen back. My orange side is going to be 6 times 15 plus 22. So that's 60, that's 90 plus 22, which is 112. And then my blue side was just x. So that side would be 15. And then my C side, which I was doing in like a pinkish purple, that's going to be 6x plus 23. So 90 plus 23 is 113. So now, how are we going to check this? Because clearly these numbers were big and it's not something you can eyeball. So if you want to just double check, we know that a squared plus b squared should equal c squared. Let's check it. So for A, we had the orange, which was 112. So 112 squared plus, and then for the B side, we just had x, which was 15 squared. And then the C side was 113 squared. So now you notice they don't actually add up to 112 plus 15. You have to square them individually and then add them individually. So let's do 112 squared, 12, 544. 15 squared is 225. So this left-hand side, let's do plus 225. That's going to be 12,769. So let's look at the other side. What is 113 squared? I don't know. Let's try it. Squared. Oh yeah, 12,769. 12769. And since those are equal, we probably did our math right.